page 288, section 4.8. We are looking at applications of the derivative to economics. Now, we've actually talked a little bit about this before. You might remember we talked about the idea of marginal cost, and we said that a marginal cost would be the rate of change of the cost with respect to the quantity of items you were making. For instance, if you're making 1,000 t-shirts, they might cost you $8 each to make, but if you're making 2,000 of them, it might go down to only $5 each to make. And if you're making 3,000 of them, then it might be only $4 each to make. And so there is going to be a rate of change of the cost depending on the number that you are making or the quantity you're making. That's the idea of a marginal cost, the rate of change of the cost with respect to the number of items that you're making. So we want to expand on that idea a little bit further today and look at some more applications to economics. So they tell me there on page 288 that in section 3.4 we introduced the idea of marginal cost. Remember that capital C of X is what we're going to use to represent the cost function, and marginal cost will be the derivative then of that cost function. Average cost, over on the top of page 289, the average cost function is going to be the total cost divided by X. Average cost is kind of like a mean. You know, you're taking the total that it costs you. Let's say that it costs you $5,000 to produce these t-shirts and you're making 1,000 of them. Then you could go through and say, okay, if my total cost is $5,000 and I'm making 1,000 of them, then the average cost is $5 each. So that's basically showing you the cost for one when you're making that quantity. And then X, referring to the number of units that we're producing. Now, if I am the manufacturer, it's going to be my goal to minimize my cost, right? At some point, I'm going to hit the absolute lowest I possibly can for producing this t-shirt. And we get the idea that the more we make, the cheaper it's going to get, but that's not always the case, because at some point, I've got to open another factory or start paying overtime or buy more machinery or something, so the cost is going to go back up. So I need to know where that bottom line is so that I can minimize my cost to eventually help me maximize my profit. So they tell me that my average cost, again, that's the cost for making one of these when I'm making, however many. My average cost is going to be at a minimum when my marginal cost is equal to my average cost. And that's in the middle of page 289. And it says, that principle is plausible because if our marginal cost is smaller than our average cost, then we need to be making more because that would lower our average cost. Similarly, if our marginal cost is larger than our average cost, then we need to be making less so that we could lower that average cost. So it's logical if we think about it in that way. To also try and help us logically understand it, in example number 1, they tell us a company estimates that the cost in dollars of producing X items can be represented by this given cost equation. So for A, it says find the cost, the average cost, and the marginal cost of producing 1,000, 2,000, and 3,000 items. So we're going to plug in some numbers just to kind of get a feel for where that average cost might be a minimum. All right, so they asked me to use the quantities 1,000, 2,000, and 3,000. We don't know that these are t-shirts, but let's just go with that. And so it says, first, find the cost of making 1,000 of these. Okay, so this is my cost equation right here. So we're just going to go through and put 1,000 in the place of X and put 1,000 in the place of X. We're obviously going to do that on our calculator. There's no need to do that tediously by hand. But if I go through and I plug 1,000 into that equation, it's going to cost me $5,600 to make 1,000 t-shirts. All right, the next thing they want me to find is the average cost. That's the cost for making one t-shirt when I'm making 1,000 of them. So if it's $5,600 to make all of them, and there are 1,000 of them, how much does it cost to make one? $5.60, right. All I'm going to do is take my total cost and divide it by the number I'm making. So 5,600 divided by 1,000 means that they cost me $5.60 each to make when I'm making 1,000 of them. Then they want me to find my marginal cost. What does marginal mean again? Marginal means derivative, yes. So let's take the derivative of that cost function. So what's the derivative of 2,600? 0. Derivative of 2x. 2. Derivative of 0.001x squared. Yep, 0.002x. Good. So there's my derivative, or my marginal cost formula. And now I want to plug 1,000 into that. So if I do, this is 2 1,000ths, right? If I do 2 1,000ths times 1,000, that would just give me 2. So I would get 2 plus 2, which is 4. All right, then they asked me to repeat that process again with 2,000 and 3,000. All right, so we could go through and say, if x is 2,000, I'm going to plug 2,000 into this cost equation on my calculator, and when I do, I'll get 10,600. Now, notice, even though I doubled my quantity, I didn't double my cost. So, hey, I'm saving some money. Let's see exactly how much I'm saving. I can take the average cost by saying 10,600 divided by 2,000. And when I do that, I get 530. What is 530? Yes, the cost per t-shirt. So now it's only costing me $5.30 each to make them. Hey, I'm going in the right direction, right? I'm minimizing my cost. That's my goal. And if I take 2,000 and I plug it into my derivative equation, I'm going to get 4 right here, plus 2 is going to give me 6. All right, then I plug in 3,000. So I plug in 3,000 into my cost equation on my calculator and get 17,600. Take that total cost of 17,600 and divide it by the number of t-shirts I'm making, 3,000. Ooh. Now they're costing me $5.87 to make. Something happened, right? Like I had to go open another factory or buy more machinery or pay overtime or something else, right? I was actually doing better when I was only making 1,000 of them than now I'm going through all the hassle of making 3,000 of them, right? So if I'm looking at this, just kind of trying to use logic and common sense, I can see there's a 30-cent difference between these two, and there's a 57-cent difference between these two. So in actuality, the 1,000 and the 2,000 are closer. It's probably going to be then that my average cost is at a minimum somewhere between those, and perhaps closer to the 2,000 than the 1,000 since that cost is lower. So that would just be my estimate. That, you know, maybe somewhere between 1,000 and 2,000, like 1,500, but maybe a little closer to the 2,000 since that average cost is lower, so maybe 17,500. I could be here all day, right? I mean, I could plug in 17,500 and then see where that left me and then go back and find another number in between these two and another number in between these two. I could plug in numbers all day long and still would have a hard time finding the exact number of t-shirts I need to make to minimize that cost. But at least now I have an intuitive understanding, a logical understanding of the answer that I'm going to get when I set my marginal cost equal to my average cost, and I'll see whether it makes sense with the table that we created. Okay, so let's set our marginal cost equal to our average cost. So marginal cost, of course, we had created right here, so we'll put it there. And average cost, we've been saying, is just your cost equation divided by x. So here's the cost equation they gave me, and we'll divide it by x. So marginal cost equal to average cost. We're going to solve that equation for x, and that will tell me the number of t-shirts I need to make to minimize the cost per t-shirt. Okay, so how do we solve this? What you want to do first? All right, let's multiply both sides by x. And then I'm going to start trying to get all my x's on one side and all my numbers on the other side, right? So when I subtract that 2x from both sides, it drops out. So then let's subtract that 1/1000th x squared from both sides. So if I subtract 0.001x squared from both sides, 0.002x squared minus 0.001x squared is going to leave me 0.001x squared. All right, so now I got all my x's on one side, everything else on the other side. Now what? Yep, let's divide by that decimal and get it out of the way. And that would leave me with just x squared. And then I'd want to take the square root to get x by itself, right? Now, typically when I insert a square root, I insert a plus or minus. However, what does x represent in this problem? A number of items I'm producing, right? We're calling them t-shirts. I can't make a negative number of t-shirts. So that's why we just consider the positive value. For AP intents and purposes, we typically round our answers to 3 decimal place accuracy. So I could say 1,612.452. But if the question asks me how many t-shirts should I make to minimize my average cost, I can't make 0.452 t-shirts, right? So I'm just going to use normal rounding rules to round that to the nearest whole number. So I need 1,612, whatever the units are that we've been saying t-shirts, but whatever it is that I'm producing. So think about what we learned from the table. All right, when we built this table, we had decided that the minimum average cost was going to be something in between 1,000 and 2,000, perhaps closer to the 2,000. And sure enough, we got 1,612. So they were trying to give us an intuitive understanding of why this process works down here so that it would be more logical for us. All right. Then the next thing that they asked me is, okay, you figured out the average cost would be the minimum when you're making 1,612 of these. What is that minimum average cost? How much does it cost me to make one t-shirt if I'm making 1,612 of them? All right, so I'm going to go back to the average cost equation. So again, the average cost equation is just the total cost divided by x. Now, I simplified that, but you don't have to. You're going to throw it in your calculator anyway, right? So we're going to take 1,612 and put it in the place of x. So if I take 1,612 and I put it in the place of x in that equation, so I'm going to put it in for this x, and this x, or if you simplified it down, put it in for this x and this x, then we end up with $5.22. That's as good as it's ever going to get. So if I can't achieve the profit margin that I want to by selling my shirts for $5.22 each, I might as well give up because I'm not going to get it cheaper than that under these standards. All right, so we've been looking at the production side of the economics. Let's switch over to the marketing side of the economics. Over on page 290, it says, now let's consider marketing. Let's let P of X be the price per unit that a company can charge if it's selling X units. So that P of X, we're going to call our demand function or our price function. They'll use those two interchangeably. So we'll represent the demand function or the price function with P of X. So again, that is the price per unit that I can charge if I'm selling X units. And of course, it depends on the demand for that unit. And it says that we would expect that to be a decreasing function of X. Why would that be a decreasing function of X? Why would my demand function or my price function be a decreasing function based on X?
Because the more something costs, the demand would go down.
I'm sorry?
The more something would cost, the demand would go down.
The more something would cost, the demand would go down. The other way that I can think of it is the more of these that I make, the demand may not be as high for them. You start thinking about the balance of supply and demand. So several different factors that we can consider with that. Okay. So they tell me that if X units are sold and the price per unit is represented by P of X, then our revenue or our sales function, R of X, would just be X times P of X. Okay, think about that for just a second. P of X is the price for one, right? X is the number I'm making. So let's say we're back to our t-shirts, and let's just use a nice round number. Let's say I'm selling them for $10 each, okay? If I make 5 of them and I sell them for $10 each, then my revenue is $50, right? Okay, so if X is the number of these that I'm able to sell and P of X is the price for one, if I multiply those, that tells me how much money I have coming in, my revenue or my sales. That's all they're saying there. Okay, and then it says that the derivative of the revenue we're going to call the marginal revenue, and that would just be the rate of change of the revenue with respect to the number of units sold. So again, there's going to be, just like we had a rate of change of the cost depending on X, we could have a rate of change of the revenue depending on X. We can have a rate of change of the profit depending on X as well. So we would have marginal revenue, rate of change of the revenue, derivative of the revenue. All right, what is profit? The money that you put in your pocket, what is that? Is that what you sell it for in the store?
That's what you make after you subtract the costs from revenue.
Yes. It's not just my sales, my revenue, because then I got to turn around and subtract my cost back off, right? So absolutely, profit then is just going to be my revenue, my sales, minus my cost that I used to produce it. And then marginal revenue, marginal always means derivative, so that would be the rate of change. So marginal would be derivative. Now, as a on the marketing side of this, my goal, of course, is going to be to maximize my profit, right? So my maximum profit is going to be found when my marginal revenue is equal to my marginal cost. And we could go back and build a table like we did for the last one to kind of get an intuitive understanding of it. We surely could. But since we've gone through that process and the logic behind it, then we can just jump straight to finding the precise value that will help me maximize my profit. So example number 2, it says determine the production level that will maximize the profit for a company with this cost and demand function. So they give me a cost function and they give me a demand function. If I want to maximize the profit, then I need to let marginal revenue equal marginal cost. Okay, well I have cost, so I could go ahead and find marginal cost. How do I do that? Derivative, right. So what's the derivative of 84? 0. Derivative of 1.26x? 1.26. Derivative of 0.01x squared? 0.02x. And then derivative of 0.00007x to the third. If I take the 3 times the 7, I'll get 21 in these last 2 decimal places right here, right? So I would have 3 zeros before the 21 there. So 21/100,000ths x squared. All right, then I need to set that equal to marginal revenue. That means I got to take the derivative of the revenue. I don't even have a revenue equation, so I got to make one of those first, right? So how do I make a revenue equation from a demand or a price equation? Yeah, multiply it by x. So remember we said that our revenue was just going to be x times our demand or price function. So this is my demand or price function, so I'm just going to multiply it by x to get revenue. So 3.5 times x is 3.5x, and 0.01x times x is 0.01x squared. All right, so now that I have a revenue equation, now I can find marginal revenue. So how do I find marginal revenue? Take the derivative of the revenue, right. So derivative of 3.5x is 3.5, and the derivative of 1/100th x squared would be 200x. Okay, so finally, I can set marginal revenue equal to marginal cost. So my marginal cost formula was over here. My marginal revenue formula was over here. Let's set those equal to each other and solve. Gonna get all my x's on one side, everything else on the other side. All right, so when I start trying to do that, if I add 0.02x to both sides, it drops out. So let's leave the x squared over here and let's subtract this 1.26 from both sides. So 3.5 minus 1.26 is going to leave me 2.24. Then what do I want to do?
Divide by 0.0002.
Yeah, let's divide by the decimal. And then what? Take the square root. And even though we get plus or minus, because what we're solving for is a number of units, it's going to be a positive value. If I'm given 3 place decimal accuracy for AP, that would be 103.280. But if I'm answering a question for a word problem that says, how many units should I make to maximize my profit, then I want to make 103 of them. Now, they didn't ask me to do this on the previous problem. They did then have me go back and plug in and say, okay, then what would be that minimum average cost? They don't ask me to go back here and say, okay, then what is that maximum profit? But I surely could. I mean, my profit function would just be my revenue minus my cost. So here's my revenue equation right here. Here's my cost equation right here. So I could do revenue minus cost and just put 103 in the place of X. And that would tell me what my maximum profit would be when I made that many. Okay? All right. So here is our homework for tonight on pages 292 to 293. For number 15, when you go to solve that problem, you're going to have a quadratic, and you're going to need to use the quadratic formula to solve it, but the b value in that quadratic is a really, really tiny number. It has several decimal places. And if you use the regular quadratic program on your calculator, it will not give you the right answer because it literally does not have enough space to put in that tiny of a decimal. So we have a second program called Quad 2 that you may have linked from me that was built specifically for this if you have a really teeny tiny little decimal. So you could use Quad 2. Probably an easier way to get around that though is once you create your quadratic equation, if you'll go through and multiply both sides of that by 1,000, then you'll get rid of that itty bitty teeny tiny decimal. That quadratic program can take really big numbers, it just can't take really little ones. So if you multiply that by 1,000 before you solve it with your regular quadratic, it'll work. Or, you know, you can always do the quadratic by hand as well. So don't forget we have our quiz on 4.7 to 4.8 tomorrow. No graphing calculators, but scientific are okay. You definitely are going to want a scientific to help you with these tedious calculations, right? So be sure you have one with you.